Okay, question 7 from November 2022. You have 3 questions to solve and the total is 12 marks. Okay, so 7.1. Determine f prime of x from first principles if f of x is equal to x squared plus x. This question is 5 marks. Okay, when you are required to determine f prime of x from first principles, they want you to use this formula. Okay, f prime of x is equal to the limit as h goes to 0. Now you have f of x plus h minus f of x. You are going to start with x plus h. You plug in there. Whenever you see x, you are going to remove x and you put x plus h. Okay, so you have x squared. You are going to have x plus h squared plus x. You're going to have plus x plus h like this. Instead of x, you have x plus h, and instead of x there, you have x plus h. Okay, you remove x, you put x plus h. You can close everything inside the square bracket. You carry on, you have minus. Now you have f of x. You're going to take x, you plug in there, right? Whenever you see x, you are going to plug this x in there. So you're still going to have the same thing. It will be x squared plus x. You close your square bracket. You can see so that you don't confuse what you are doing. This is over h. You carry on. This is equal to the limit as h goes to 0. Now you are going to expand this bracket. Okay, so you have x squared. You have x times h times 2, which will be plus 2xh. Okay, plus 2xh. And then plus h squared. Okay, this is what you get when you expand this bracket. Okay, let's carry on. Plus x plus h. You have negative in front of this bracket. Okay, so you are going to have minus x squared minus x because of the negative in front of the bracket. Okay, this is over h. Now you can see you have x squared minus x squared. This is 0. And you have plus x minus x. Okay, plus x minus x. This is 0. So you only remain with the terms having h in them. Okay, you have this, this, and this. So let's carry on. This is equal to the limit as h goes to 0. You have 2xh plus h squared plus h over h. This is equal to the limit as h goes to 0. Now you are going to factorize h outside of the bracket. So you have h outside of the bracket, and in bracket you have 2x plus h plus 1, right? Plus 1 when you take h outside of the bracket over h. Now you can cancel. This is equal to the limit as h goes to 0 of this. Now you can substitute 0 for h. You are not going to have division by 0. So whenever you see h, you are going to substitute 0 for h. So you are going to have 2x plus 0 plus 0 plus 1. Okay, this is the only time you are going to drop this. When you start substituting 0 for h, you are going to drop this part. You can see I don't have this part here. Okay, so you have this. This is equal to 2x plus 1. Okay, so this is your final answer. Let's move on to question 7.2. 7.2. Determine f prime of x if f of x is equal to this. This question is 3 marks. You are not required to use the first principles. So you can use the laws of differentiation or the rules of differentiation. Okay, so f of x is equal to this. This is what you are given. Okay, so f prime of x is equal to 5 times 2, it's 10, x to the power of 5 minus 1, which is 4, minus 4 times 3, which is 12x to the power of 3 when you subtract 1 from the exponent, plus 8. Okay, this is the final answer. If you are still struggling on how to use the laws of differentiation, please check lesson 2 of 6 on calculus grade 12. Okay, now let's move on to question 7.3. 7.3. The tangent to g of x is equal to ax cubed plus 3x squared plus bx plus c as a minimum gradient at the point -1 and -7. -1 is your x coordinate and -7 is your y coordinate, for which values of x will g be concave up. For marks. To determine where the graph is concave up, we need the second derivative. Okay, to determine where the graph is concave up or where the graph is concave down, we need the second derivative. Okay, g of x is equal to this. This is what you are given. Let's get our second derivative. So before we can get our second derivative, we need our first derivative first. Okay, so the first derivative, g prime of x, is equal to 3 times a, which is 3a, x to the power of 2 when you subtract 1 from the exponent, plus 6, right? 2 times 3, 6, x to the power of 1 when you subtract 1 from the exponent, plus b, and then plus 0. This is a constant. Now let's get our second derivative. The second derivative is equal to 6a x to the power of 1 when you subtract 1 from the exponent, plus 6. I hope you know how to use the laws of differentiation. So this is the second derivative. To determine where the graph is concave up, you are going to take the second derivative. You make it greater than 0. Okay, for concave up, greater than 0. If it concave down, less than 0. Okay, so this is why we have greater than 0. We are going to solve for x. So you are going to have 6ax greater than, you take this to the right. Now you have -6. You are going to divide by 6a so that you can determine x. You divide by 6a, you are going to have x greater than -6 over 6a. Okay, now you don't know a. You are told that the tangent to g of x has a minimum gradient at the point, at this point. This is what you have to remember. Okay, maybe you have to write this down. A tangent to a cubic function will have a minimum or maximum gradient at the point of inflection. Okay, let me say this again. A tangent to a cubic function will have a minimum or a maximum gradient at the point of inflection. So for example, let's say you have this cubic function and you have a point of inflection, or the inflection point. A tangent that is touching this cubic function at the point of inflection, like this. This tangent will have a minimum gradient, okay, because it is a line which is decreasing. It will have a minimum gradient, okay. And for example, let's say you also have this cubic function with a point of inflection, right? This is the inflection point or the point of inflection. A tangent line which is touching this cubic function at the point of inflection will have a maximum gradient because it's increasing, okay? So whenever you have a tangent touching a cubic function at the point of inflection, that tangent will have a minimum gradient or a maximum gradient, okay? So the second derivative is equal to 0 at the point of inflection. So we are going to let it equal to 0 so that we can get the x coordinate. Now, when you check the question, you have that x coordinate. This is the x coordinate of the point of inflection. Okay, so you have 6a times x. X is -1. This is equal to, you take this to the right. To get the value of a, you're going to divide by -6 on both sides so that you can solve for a. You divide by -6, you have a is equal to, you have 1. Okay, negative 6 divided by negative 6, you have 1. Now you can substitute 1 for a. So x greater than negative 6 over 6 times 1, a is 1. This gives you x greater than, this is negative 1. So for x greater than negative 1, the graph is concave up. Okay, you can also give this answer like this. X element of from negative 1 to positive infinity. Okay, negative 1 to infinity. All these values, the graph is concave up. So we are done with question 7 from November 2022. Until next time, I will talk to you soon.